Hello everyone, it's Benny, and today we're going to be continuing development of the 2D role-playing game that we started in Video 7. So, just as a quick recap, so far we've created a basic game engine, we've created a player, we've also created an animation system, which we're not using right now, and we also set up some statistics for the player and basic leveling. So that's all we've done so far, and in this video I hope to not finish, but at least get a slightly less temporary version of the leveling system in place, and I'd also like to go ahead and implement items. So, with that all out of the way, let's go ahead and get started. And the first thing I'd like to do is I'd like to go ahead and implement the less temporary version of the leveling algorithm, just because XP over 50 is a little bit too simplistic for my taste. So I'm just going to go ahead and implement our final leveling algorithm. So, I spent some time, and I sort of came up with it. I more or less just played around with numbers until I got something that worked, and I originally was going to do a sort of in-depth explanation of how I came up with it, but it ended up taking about 15 minutes, so I decided I'm going to cut that part out, and I'm just going to show you the algorithm. So, first part of this algorithm is it requires a constant. So I'm going to create, actually not here, not sure why I was thinking, but I'm going to create it up here. It's going to be a public static final, and it's going to be a double because we need the extra precision in this algorithm. It'll be level const, that's just what I'm going to call it. It's what I called it when I created it, so it's what I'm going to call it. And here's what it's equal to. It's equal to math.pow, so it's raising some number to a power. And we're going to be raising 3 to the free half power. And it might seem weird, but it's the number I came up with when I was playing around with numbers to create the algorithm. And I multiply this by 25. And again, I just sort of played around with things, and this is the constant I came up with. And so, now that we have the constant, we can go down here and actually implement the algorithm. So, first thing I'm going to do is I'm going to do the simple part, because this is a fairly complex algorithm, so please pay attention. The first thing I need is some variable to keep track of the experience that I'll use in calculation. Because while the experience value that we have just being stored is nice, this algorithm places level 1 at 105 experience. And that's fine if you want the player to be level 0 at some point, but well, I don't. So I'm just going to create a double called x for the experience being calculated, and I'll set it equal to xp multiplied by, xp plus 105. And that way, we're just calculating so that level 1 will be set to 0 experience. We're just shifting our experience by 105. So in a sense, we get 105 free experience in this algorithm. So now comes the hard part. Now is when we actually implement the algorithm. So I suggest you pay close attention because this is somewhat complicated. So now, let's just go ahead and implement it. So the algorithm is based on 3 variables, and I called these just double A, double C, and double D. And there's a reason why I skipped B, but that goes into the in-depth explanation of how I came up with this, so just for now, trust me that I'm not crazy, there is a good reason why I skipped B. So, now let's go ahead and implement A. So what is A going to be equal to? Well, to get A, I took the square root, so math.square root, and I took the square root of a quadratic expression. I took the square root of a quadratic expression. And that expression is 243 times x squared, so multiplied by x times x, plus 4050 times x, plus 17,500. And what this variable is doing is, in the general scheme of the equation, is if you look at most leveling algorithms, you'll know that at experience required to get to the next levels generally exponentially increases. That's what this quadratic expression is doing. And the reason I'm doing the square root of it is because I'm calculating my level based on experience, and because of that, I'm not actually looking for a exponential curve, I'm looking for a logarithmic curve. And the square root, it doesn't exactly give you a logarithmic curve, but it gives you close enough to the shape that I'm willing to just take a square root instead of trying to do the math to get it into a logarithmic form. So that's what variable a is doing. So now let's talk about variable c. And just like variable a, I'm going to sort of write it out first, and then explain what it's supposed to be doing. So, what I came up with was c was equal to 3 times x plus 25. And then that expression divided by 25. And what this does is it produces a linear equation. And the idea here is that we're going to, in some form, combine c, which is a linear equation, and a, which is an exponential equation. Because since c is linear, it provides a very steady increase, and since a is exponential, it produces, well, it produces an exponential increase. It provides an increase over time, which is generally what you want in levels. You want levels to become gradually harder and harder to get at, but you still want them to be gained at a somewhat steady pace. And I'm going to achieve this by simply combining a linear algorithm with, a linear equation with a more exponential equation. And variable d is where all of this is going to come together. So, d is going to be the combined a and c. So, the way I did this is I just took a and I added c to it. And that might seem a little bit simple, and that's because it is. Because as it turns out, this isn't exactly what I want, so I had to do a little bit more to it. First off, a, it didn't sit quite right with me. It seemed it wasn't producing quite the curve that I wanted, so I sort of normalized it by creating the leveling constant. That's what the constant we created does. I just take a divided by level const, and that will alter the rate at which a increases, and therefore it'll sort of normalize it a bit, and it'll make these, it just makes it fit a little bit nicer in my opinion, and that's why I have a leveling constant. But this as a whole was still off. While I solved the problem with a being off, this when combined is still a little bit off from what I wanted. So what I did is I just took the cube root of it, because the square root just didn't quite cut it. So I did this cube root. I wanted to take it a little bit further in this case. And I think it made it work out pretty nicely. And that's all d really is. It's what you get when you combine a and c. And now that we have this, pretty much the whole algorithm set up, we can finally return something. So you might be tempted to just return d. And there's nothing inherently wrong with that. The only issue is that when I created d, it seemed to produce levels that were about a third higher than what I wanted. I want levels to be just a little bit slower. They're about 1/3 too high. So, the way I solved this is I just took d and I subtracted 1/3 of d. So that's 1.0 divided by d times 3. And this pretty much finished the algorithm. The only thing I did was I subtracted 1, and I don't really see why I didn't realize this before, but I could have solved the issue with this algorithm starting at level 0 by just getting rid of that -1, so I'm actually going to solve that right here by changing this to just x is equal to xp. And in fact, I can even get rid of this and just do all the math directly with xp. So just change everywhere that's the x to xp. And now, that should complete my get level algorithm. So, let's go ahead and test it out. So right now I have 0 experience, so I should be level 1. So I hit run, and according to my output, I'm level -1. Okay, so I guess I really did need that -1 in XP thing. So I'll just go in here, do -1, and create double X again. I know, I'm sorry, but I guess I just had fault lapse. This doesn't work. But again, like I said, I just mostly came up with this by just playing around with things. And if you want to create your own, then you can just play around with numbers and equations until you get something you're happy with. And this should be the correct algorithm. So now I'm on level 1, just like I want. Excellent. So now, if I increase my experience to, say, 100, I should still be level 1 according to this algorithm. I am, good. Now if I change to 112, that should be the most experience I can get while still being level 1, because level 2 should be at 113. So if I change it to 113 XP, I should have leveled up. And I didn't. So the question remains is why I did not level up. Let's see. If I only did it slightly wrong, I'm just probably going to leave it. So, okay. Actually, maybe it's 113 the most you can be at level 1. Maybe I just got... that's off by 1. Oh, yeah, I had it off by 1. 113 was the most you could be at level 1, not 112. Okay, so... sorry about that. And, yeah, so 114 is the minimum experience required to be level 2. Okay, so that completes the leveling algorithm and the most boring part of this video, so... thank God that part's done. So, now that we did the hard and not as interesting part, let's go ahead and move on to the other part. I want to create items. And items aren't that hard to create, they just require a little bit of know-how to do. So, first off, I'm going to right-click on my base.game.gameObject package, and I'm going to create a new package. It's going to be called com.base.game.gameObject.item. And this is because item is going to be its own category of game object. So now I'm going to create, in this new package, I'm going to create the item class. And of course, this is going to extend game object. And this is going to be the base for every item in the game. And this isn't working because I need to do Control-Shift-I. And now I have the item class all set up. Excellent. But there's a pretty big problem that we encounter right off the bat. Picture this scenario for me. We are in our finished game, we're in our player, we're running around in some village or something, and then we run into a wall. Now, what you want to happen is you want the player to just stop moving, because, hey, they hit a wall, they shouldn't be able to move anymore. That part's pretty self-explanatory. But, let's say I'm running around, and then I run into an item. The way I want this game to work is I want it to be run over items to pick them up. So I would want the player to pick up the item. That's a problem. Because when we're doing collision, we're only checking if we hit something. So in addition to that, we'll need some way to keep track of what's an item and what's just another game object. And the way I'm going to do this is I'm going to go to my game object class, and I'm going to keep track of another type of data. So I'm going to create a protected int, and it'll just be called type. Every game object will have a type. And if you don't specify one, then it's just going to be 0. So, in my initialization thing, I'm going to take in an int called type. And in here, I'll just do this.type is equal to type. And this will be the way we determine what's an item and what's not. You could say that everything that's just another game object has a type of 0, so that's the average game object. And we could say that all items are type 1. So that way, when we hit something, we can at some point change the physics system to return what object we hit, and then we can just use that object and say, okay, is this type 1? Which would mean it would be the type of an item. And if it is, then we pick it up. So, that's pretty much exactly what we want. So now, with that done, let's create this type method, let's create a getType method, because we'll need some way of getting the type out. So I'll create a public int getType and just return type. This will let us always access whatever type our game object is. And of course this changes our initialization for the player because we need to specify our player's type 0. And And, I'm actually debating on which order I want these parameters in. And I actually think I want the type at the very end, so I'm going to change that around a bit. I'm going to change it to int type at the end, so at the very end int type. And it doesn't matter really, but I just want it that way. So now we have a way of determining what's a player, what's an item, and what's anything else we ever want to identify. We have this type number that categorizes every game object. And that's exactly what we want. So now we can go ahead and implement the item class. So to start off with, what is every item ever going to have? Well, first off, I want every item to have some name. Because, I just think it makes sense that every item has some name. It doesn't make sense to have an item that's just unnamed. So I'm going to create a private, protected string. That'll just be name. And that way we can just keep track of whatever name we want for our item. And other than that, I really think that's the only thing that every item in the game absolutely needs. Other than at some point, of course, it'll need some sprite so that we can keep track of it. In fact, why not? We'll keep track of some sprite, SPR, but actually let's keep track of it in the game object, so we don't need that at all, actually. I actually think that is everything that we need for the item class. So, with that done, we can go ahead and implement the methods, which the only new method we need for items is a pickup method, something that we're going to do whenever we pick up the item. So I'm going to create a public void that's going to be called pickup, and that'll be whatever it does when you pick up the item. And the one other thing I want to do before I go ahead and implement an example item is I want to override the init method, because I want initialization for item to include the name. So I'm going to import the sprite class, and I'm going to do @override so NetBeans doesn't hate me forever, in capital O, and just tab all that over. Okay, NetBeans is being a pain. That's okay, I guess. So now everything is spaced correctly. And the one other thing I want to take in is... Actually, I'm not even going to take in a type, because I don't... Every item is going to be type 1. So I'm going to set this type equal to 1. That's going to specify an item. But the thing I'm going to take in that's new is a string name. And I'm just going to set my name equal to name, whatever name we pass in. This just gives us a nice, easy way to name all of our items. And this is giving me an error. Method does not override or implement a method from a supertype. Okay. There. Oh, okay, I guess that doesn't need to be overridden for some reason. And I'm getting an error in my player class according to this. Why am I... Okay, it's just issue of NetBeans. Alright. So this is pretty much the setup for our item class. All of our items are going to be based on this. And I'm going to create an example item, just so we can test it out. So I'm going to create a new... Not named item, but... I do want to call it something. What do I want to call it? I'm just going to call it... Well, what would be a good item to have? Well, what should be a good first item? I'm going to call it cube. Yeah, just because, why not? Maybe they want to pick up a cube. And our cube is going to be an item of some kind. And now, in our constructors, so public cube, public cube, and I'm going to init, and now for my initialization, I need an x position, so I forgot to take those in, float x, and float y, and initialize using x, comma y, and then if I remember correctly, I need a red, green, blue, and x and sy. So what color do I want it to be? I'll have it 1 in red, a little bit of green, and no blue. So it's going to be slightly purple, slightly pinkish cube. And other than that, I really should have this method memorized by now, but oh well. It's going to be size, comma size. I'm going to specify that later. And I'm just going to call it cube. Actually, I'm going to call it the cube, just to make it that much more epic. I'm going to create a constant for size. It's public static final float, because why not? Size equal to 32. Did I make it float in player? Yeah. Okay. So we have a floating point value for our size that's equal to 32. And we've pretty much done everything we need to create an item. The only thing I'm going to do is I'm going to override the pickup method, so public void pickup. And in the pickup method, I'm going to print out, you just picked up a plus name plus exclamation mark. So this should just say, you just picked up, actually I'm going to delete the A, you just picked up the cube. And it's going to be all epic and stuff, and yeah. So, let's go ahead and delete this line because we want to make sure we know when we pick up an item. And now let's go to the game class and just add the cube to the world and test for collisions with the cube. So, I'm going to create in here, just do objects.add, and I'm going to create a new cube at position. What position did I put the player at? Okay, I'm going to put the cube at position 32, 32. And I'm just going to see if that does anything. We won't be able to pick it up right now because, okay, we have an error. New cube. Oh, Control-Shift-I. We need to import it. And now if I hit run, we should have a cube in the corner. And it's actually an orange color. Of course, if we hit it right now, it doesn't do anything because we aren't doing any collision detection. But we do have the cube showing up. And that's good. So, now let's actually test for collision. And the way I'm going to do this, I'm just going to pass in the player as a parameter. And this is really going to be more of a temporary way of doing. Actually, I might keep it this way, I'm not sure, but for now I'm going to do it this way, just because it's easy. I'm going to take in the player as a parameter, so I'm going to take in a player play as a parameter. Import. Definitely not the best way to do it, but why not? It works. And set this dot play is equal to play. Actually, this dot player is equal to play, and I just need a player variable. So I'm going to create a private player. Just call player. And this should, yeah, it should be keeping track of it. And now in the update method, so public void update, I'm going to test for collision. So if physics.check collisions between this and player, then pick up. And now that should be displaying this message whenever we come into contact with the cube. So, if I run down really quickly, you just picked up the cube. And you notice it's displaying it like a million times and not actually getting rid of the item or anything spectacular. So that's a bit of an issue. So, now that we've done all that, we need to implement the getting rid of the item and adding the item to the player. So, the way I'm going to do this is simply enough. I'm going to add another method to our player. It's going to be a public void add item, takes in an item, and for now, we'll just print that we just picked up an item. And I need to, of course, do Control-Shift-I to get item. And now our player class should be working if I save. And in our pickup method, I'm also going to do player.addItem this. And that should add the item to the player. Or do whatever we need to do to add the item to the player. The only final issue that we have here is that we want to get rid of the cube once it's actually done, once it's gotten rid of. So this can be a slight issue, but we'll just have to do a little bit more work to get this item to be removed. It will be done with the game, because the game's what's keeping track of all the items, all the objects, everything. So I'm just going to create a public method, and it'll be called just remove object. Take in some game object go. And what I'm going to do is I'm going to do for each game object go in object if go is equal to, oh, whoops. I'll just take in, I'll call this one I'm passing in the target. So if the game object is the target, then object.remove go. And that, right there, should be able to remove some object from the game. The only problem is now, well, our game, it really doesn't... What am I saying? Excuse me. We need to know about the game, because we need to call this method. So I'm going to pass in the game as a parameter to our cube. And I'm going to take in a game. And, in fact, I think it's fair that every game object should know about the game it's in, so I'm just going to create that as an inherent part of the game object class, because I think it's fair that every game object should know about the game it's in. So I'm going to create a protected game called game, and whenever we create a game object, Control-Shift-I, we will need to let it know what game it's in. So now I just need to figure out how I want to do this. Naturally, that's a little bit more complicated than I want to really worry about. I'm probably going to go back and do it later, but for now, I'm going to just do it in the item or the cube class, and we'll work out a better way of doing it later. Right now, I just want something that works. Because, again, that's the whole theme of this step 2, isn't it? Get something that works. So I'm going to pass in the game as a parameter. So game, and this dot game is equal to game. And once we're picked up, we do game.remove object this. And that should pretty much delete this object. Not exactly, but it should pretty much, and oh, I just need to pass in the game. Okay. And that's right there. It should be removing the cube from the game. So if I hit run, then when I hit collide with the cube, it crashes. Okay, so now we need to check. It's because of the for each loop. And this has actually been causing me a lot of problems, so I'm actually going to do this a much simpler way that I'm surprised I didn't think of first. So I'm going to delete all the junk with passing the game and everything, all this, and that should be error-free. Why are you giving me oh? Yeah, get rid of all the junk with the game. I don't want to pass in the game anymore. I want something a little bit different. I'm going to have a way of talking to the game class without referencing the game class. And the way I'm going to do this is I'm going to use flags. So I'm just going to do, they're going to be pretty much like booleans, but if I change one to true, it's going to cause the game class to do something. So what I'm going to do is right here, I'm going to have, I'm going to have a flag, which is just going to be a boolean variable. It's going to be called remove, which I'm just going to default to false. And here, I'm just going to set remove equal to true. And what this is going to change is if I do Control-Shift-I to fix imports, because it clearly isn't happy. And I'm going to do Alt-Enter to fix all this, just to make NetBeans happy. And now I have the remove flag set to true. And now here's the interesting thing. What I'm going to do is, in here, I'm going to do the update method, but I'm going to do if excuse me, I need to have a get method for it. I'm actually debating whether I should make this public. I'm just going to do get method. So public boolean get remove, and it's just going to return remove. Okay. So if geo.getRemove, so if we're not going to remove it, then we're going to update it. Otherwise, we're going to flag it for removal. And we're going to remove it on the next iteration. So, I'm just going to create a second array list called private array list of game objects called remove, and I'm going to, in here, just set remove equal to a new array list of game objects. And if we are not updating it, then you're going to remove.add geo. And this will just be a list of every object we want to remove. And we can't remove it directly, because if we do, then we'll have an error, because we're going to try to, well, because we're using this array list in multiple places. We can't do that. So instead, I'm going to wait until the next frame, or until the next, I'm going to wait till the end of the update cycle, and then I'm going to just do for each game object, geo, in remove, I'm going to do objects.remove geo. And that should enable the remove behavior that we were looking for. So if I run over to it now, it allows us to pick it up, and it gets rid of the item, pretty much. So, good, this is exactly what we want. If I run over it, oh, okay, this is interesting. If I do run over it on the x-axis, it counts as picking it up. If I run over on the y-axis, it doesn't do anything. Okay, so we apparently have some problem in our collision system. So, let's go to the physics class and look at this, and I see what our problem is. The problem is we're passing in the variables in the wrong order. We're passing in x and then width, then y, then height. Rectangle doesn't take parameters in that order. It takes width, or excuse me, it takes x, y, width, height. So I just need to switch my width and my y variables. So I'm going to just change those around. I'm just going to change that to int geo1.getSX. And to here, I'm going to do int geo2.getSX. And that should fix our collision error. So now if I run this way, it doesn't pick it up, and it won't pick it up at all until I actually hit it. So good, we now have basic items working. So I actually think I'm going to call it here, because the next step is adding in inventory system, and I think inventory system is going to be a little bit on the complicated side, so yeah. I think we did a fair bit of things in this video. We managed to get basic items working, at least, which is exactly what we want. So we have the item class, we have our cube, which doesn't do anything yet, but we can change that later. And we have this new flag system, which allows us to flag things for removal from the game engine, which is good because that's something that we'd, it's very useful. It allows us to remove things from the game, essentially. And yeah. And actually, just because I can, I'm going to have a remove method in the GameObject class. This be a public public void remove, and I'll just set remove to true. That way, we can sort of hide the way that we are removing objects, and if we need to change it later, we can change it without affecting the code. And I'll go to the cube class, and just call the remove method instead. So there. We now, more or less, have completed basic items, and we've also finished a basic leveling algorithm for the player. So hope you enjoyed, and I hope you're ready for the next time, when we'll probably be doing inventory, which is a pretty big subject. So thank you,